All right, so a quick walkthrough for activity 234. We're using the product rule in conjunction with the rules that we've learned so far. So this can be a little confusing at first because we don't know how to view the structure of these things. And so I'll give you some kind of pro tips on the way that I view them. And the first is that I go hunting for brackets. So I'll explain what that means in a second. So let's write down what f of r is here in this case. To cos r, we're looking for the derivative. So I go hunting for brackets to kind of seek out the structure of the function, right? This is a combination of a bunch of different functions. So the question is, what is the outermost structure of this thing? So really you've got, this blob here times this blob here. These two functions that live inside of brackets, okay? And so what we see is that we've got something times something as the outermost structure of this function. So again, you can get kind of lost in the details like, oh my gosh, there's a power function, there's a sine, there's a cosine, there's an exponential. The goal of this is to reduce and break into chunks the problem. Okay, so we've got something times something, and again, so we can think of this as some f times g or some blah. It's like some blah 1 times some blah 2. Okay, we know from the product rule. I'll just sketch the little area thing that if I had some blah 1, some f, some blah 2 times g function, that when we mess with these, we add some little df and some little dg. What do we get? We get these little wedges. That's, df times g of the length of g. And over here, this is like dg times f. And so that's why that's the total change of this thing includes the derivative of each of them separately. So we get blah 1 prime times blah 2 as it was, plus blah 1 times the derivative of blah 2. Okay. Forgive the quality of the voice today. So this is what we've got. So what this does, again, we chunked it by breaking it into little blobs. Again, hunting for brackets is a better way to say this. And then from there, the problem simply becomes, all right, what is the derivative of each of these blobs? And yes, I'll stop saying blahs now. So now I'm just thinking about the derivative of the green function. Well, that splits over the derivative of a power function. So we get ddr of 5r cubed plus ddr of sine r, which is really 15r squared plus cos r. Okay, so that's this piece here. And then for my second function, the derivative of that piece, well, derivative of 4 to the r, and then we can do, minus 2 derivative of cos r, because remember you can pull out a scalar from differentiation. And so derivative of 4 to the r is just 4 to the r times the ln of 4 minus 2 cosine of r. The derivative of cosine of r is negative sine, so we actually get a plus 2 sine of r here. All right, and so this is where we get our derivative of our second wedge. All right, so then in total, then f prime of r is blah 1 prime. So that's this guy, 15r squared plus cos r times our second piece just as it was, right? It's kind of just the length of that rectangle without messing with it. Plus, might need to give myself some room here. Plus, oh, cooperate with me, please. Here we go. First chunk, which is just 5r cubed plus sine r times the second derivative, which is that one we just found, 4 to the n ln of 4 plus 2 sine r. Now from here, life isn't going to get much simpler, so I'd actually just leave it unsimplified. There might be something else you can do, but probably not worth it. Okay, so at this point, it's just we've executed the derivative rule. We've got it. We can leave simplification for another rainy day.